Okay. Hi, this is group 22. The chapter we select is topic 1, is about chapter 5. I am the group leader, Chong Zishan, and the group member, Chin Fox Sin, No Aliyah, Natasha binti Muhammad Rizal, dan, and Lee Kwang Shi, sorry, and Lee Kwang Shi. So this is the content table. I would like to talk about what is preemptive SJF and question 1 and solution. Okay, first, what is the preemptive FJF? You can see this preemption, the CPU can switch between process if a new process with shorter burst time arrive. The second is the process with the shortest burst time or remaining time is already chosen for the execution. The goal is to reduce the average waiting time by prioritizing shorter job. The fourth is as process arrive, the schedule dynamically re-evaluates which process to execute based on the remaining burst time. And now, okay, this is the questions one for preemptive HF. At the left, you can see this. The table is the table is the original table, and the right, this is the table I arranged by arrival time. You can see 0, 3, 5, and 10. And now I want to show the step of solution, how to do the preemptive SJF. Let the animation run first. Okay, you can see the P1 execute time equal to 3 because 3 minus 0 equal to 3, right? So the P1 remaining equal to, I move my window first, okay? You can see the P1 remaining time equal to 15 minus 3. The 15 is the burst time, and the 3 is execute time. Like 3 minus 0 equal to 3. So the execute time equal to 3. So 15 minus 3 equal to 12. So the process 1 have 12 left. Okay. Uh, and then the P1 will stop at times 3 because the arrival time of P4 is 3. You can see the arrival time of P4 is 3. Okay, the P4 arrive, arrival time is 3, right? With the burst time 11. So the CPU will preempt the P1 because the P4 has a shorter burst time than the P1. You can see the P4, right, have a burst time 11 is shorter than 12. So the CPU will, so in preemptive SJF, the CPU will process the P4 first. Okay, you can see, sorry. Okay, you can see the P4 execute time equal to 2 because 5 minus 3 equal to 2. So the P4 remaining time 1 equal to 11 minus 2 equal to 9. The P4 is not complete yet because have 9 left. Okay, you can see 11 minus 2 equal to 9. The P4 will stop at time 5 because the arrival time of P2 is 5. You can see the timetable. The arrival time of P2 is 5. Okay, the P2 arrival with burst time 9. So now the burst time P2 and P4 is equal, right? But the CPU will continue to execute P4 because the P4 is already processed. So you can see the calculation. The P4 execute time equal to 5 and the P4 remaining times 2 equal to 9. 9, 9 is from the P4 remaining time 1. Okay, P4 remaining time 1 minus execute time equal to 4. The P4 has not complete yet. You can see 9 minus 5 equal to 4. Uh, the, the P4 will stop at times 10 because the arrival time of P3 is 10. P3 and above with burst time of 5. Since the P4 has a remaining burst time of 4, right? The P4 remaining time is 4, right? So the CPU will continue with P4 because the 4 is the shortest burst time. You can see 4, 5, 9, and 12. The 4 is the shorter burst time. So the CPU will continue process P4 until it comes to 0. You can see the calculation. The P4 execute time equal to 4, and the P4 remaining times 3 equal to 4 minus 4 equal to 0. The P4 is complete. The P4 now stop at times 14 because the remaining time equal to 0 is complete, right? So it's preemptive at time 14. Okay, now the P4 is finished executing. The CPU will looking for the remaining process P2, P3, and P1. The CPU will find out who is the shorter burst time. The shorter burst time is process 3, right? So the process 3 will continue process at times 14. Okay, you can see the calculation. The process 3 execute time equal to 5, and the P3 remaining time equal to 5. The 5 is the burst time, minus 5. The 5 is the execute time. 19 minus 14 equal to 0. The P3 is complete. The P3 stop at times 19 because the burst time of P3 is already become 0. So the process 3 is already finished. Yeah, you can see 5 minus 5 equal to 0. Okay, the P3 is finished execution. Then the CPU will choose the P2 to continue execute because the the P2 has 9 unit of time remaining, is shorter than 12. So the CPU will continue P2. You can see the calculation. P2 execute time equal to 9. The P2 remaining time equal to 9. 9 is the burst time minus 9 execute time. You can see 28 minus 19 is the is 9, right? So the burst time minus execute time equal to 0. The P2 is complete. 9 minus 9 equal to 0. Okay, then the P2 will stop at time 28 because burst time of P2 is already become 0. Okay, the final is P1. After the P2 finish execution, the CPU will switch back to P1 because the P1 is the first process, right? He will switch back to P1 for process the remaining time 12. The calculation is P1 execute time equal to 12. The P1 remaining time 2 equal to P1 remaining time 1 minus execute time equal to 0. So 12 minus 12 equal to 0. Now P1 is finished execution and all process are complete. And next is the how to calculate the average waiting time. Now I want to show about waiting time calculation. First, P1 equal to 0 minus 0 plus 28 minus 3 equal to 25. How to get the 0? The 0 is the starting time of P1. You can see this is 0 minus the arrival time. So this is 0 minus 0. How to get the 28? 28, you just see the last P1 process, right? The starting the starting time is 28. So you just take the 28 minus 3. The 3 is taken by the preemptive time P1. You can see the preemptive time, they stop at times 3, right? So 28 minus 3 equal to 25. For next is waiting time of P2. How to get the 19 minus 5 equal to 14? You just see the process P2, right? The process P2 start at 19. So you just take the 19 minus the arrival time. So equal to 14. Next is P3. How to get the 14 minus 10 equal to 4? You just see about the starting time of process 3. You can see the starting time of process 3 is 14, right? So you just take 14 minus the arrival time. The arrival time is 10. So 14 minus 10 equal to 4. Next is P4. You just see the P4. The the P4 start at uh times 3, right? So you just take times 3 minus the arrival time equal to 3. So this is equal to 0. The another P4 is no need to calculation because this is uh continuous. Continuous is mean this is continue with non-stop, right? The P4 is non-stop, so it's just take the starting time minus the arrival time. So the average equal to 25 plus 14 plus 4 plus 0 uh, divide by 4. So you can get the average is 10.75. Okay, thank you.
Hey, good morning, everybody. My name is Chin Fuxin. Welcome to Group 22, Chapter 5 of our topic is Preemptive, which I will do a preemptive priority. Group leader is Chong Zixuan. One of my group members is No Arya Natasha bin Muhammad Rizal and Lee Guanxi. Okay, so what is preemptive priority? Preemptive priority is a priority-based process, which is like a smallest integer gets the CPU first. For example, like 1 or 0, 0 will get the priority first because it has the highest priority because of its smallest integer. Then, right now, I will present to you with our table that is right here, provided by Alia. Okay, so this one right here is the table that one of our question. So right here is the process right here. Okay, we have a process. We have already been doing the table or the arrangement. So for example, like P5 arrival time is 0, P1 arrival time is 1, P4 arrival time is 2, P2 arrival time is 4, P3 arrival time is 4 milliseconds. So first of all is we will like to present is P5 will be executing first because of his 0. His integer is 0 because arrival time in 0 millisecond. Process will be first, then it will execute till 1 millisecond because right here P1 will be entering through the arrival time of 1 millisecond, but P5 will still continue because of P1 lowest has the lowest priority, which is 4. So P5 will be executing first of 1 millisecond and burst time of 5 milliseconds. So 5 minus 1 become 4 millisecond. P5 have remaining time of 4 millisecond. Then P5 will start executing at 1 millisecond. That means will start executing to 1 to 2 millisecond because the next one is P4. P4 will be arriving through here of 2 milliseconds. So P5 will be interrupted by P4, but because of P5 higher priority, P4 will still not be executing here because P5 will still continue because of his higher priority. Then remaining burst time is 3 for the P5. Then next is P5 will be executing through 4 millisecond. 4 millisecond because P2 and P3 will be entering right here, right? So P2 will start executing because of his highest priority. By the way, just now P5 remaining burst time is 3, right? Right now, execute time is 2, which P5 will become 1 millisecond for the remaining burst time. P2 then will start executing at 4 millisecond to 12 millisecond because of his highest priority and burst time of 8 millisecond. So the deduction will be 8 burst time minus 8 execute time become 0 millisecond. So then P3 enter because of his next highest priority is P3. P3 will then go to 12 millisecond to 14 millisecond, which is a 2 millisecond burst time. It will execute also 2 millisecond. That's mean the total remaining burst time for P3 is 0, which is completed. Then it will go next to P5 back, which is the next highest priority. Next highest priority is P5. P5 will then remain 1 millisecond left. That means 14 to 15 millisecond. P5 will be using his remaining burst time of 1 millisecond. As you can see right here, 1 millisecond. Then P6, sorry, no, not P6, sorry. Okay, then P4 will be executing of at 15 millisecond to 22 millisecond because of his next higher priority and the burst time of 7. P4 will then execute till 22 millisecond. Okay, so this one right here, we can see that now P4 is finished. The last but not least is P1. P1 will be 22 to 28 millisecond, which is a 6 millisecond process because of his burst time of 6 and execute time of 6 millisecond. So the process is done. We will go to the total waiting time. Total waiting time right here is P1 waiting time is 22 minus 1, which is become 21 millisecond because it start at 22 millisecond, which arrival time is minus 1 of his formula. And next is P1. P2. P2 is next because of arrival time is 4, and then start executing at 0, at 4 also, sorry. And then we become 0 millisecond. Then next is P3 waiting time. P3 waiting time will be 8 millisecond because 12 arrival time of 4 and 12 because it start executing at 12 millisecond. P4 waiting time is 13 millisecond because of his 15 millisecond executing time. Start executing at 15 millisecond and arrival time of 2 millisecond. P5 here will then be total of 10 millisecond. As you can see right here, arrival time is 0, and then the start executing time is 0. Then the next one right here, right, is the next is 14 millisecond where he's start executing again, and the next one is where it end is last execution time. So it become a total of 10 millisecond. So the total waiting time is 52 millisecond. The total average waiting time is 10.4 millisecond because 52 divided by 5 of the process. So now is 10.4 millisecond total average waiting time. So that will be all for the preemptive priority on the waiting time calculation and the how to calculate the executing time. So thank you very much.